welcome to my channel. So in this video there are two goals. The first goal is to see how to solve this problem, and the second goal is to see how you should behave in a real code interview. And at the same time we are going to do some live coding. So before we start the real content for today, I would really appreciate that if you can help subscribe this channel because it can help me to grow. So thanks a lot. So let's get started. The first step in the real interview is always try to understand the problem. If there's anything unclear, please clarify the unclear part with the interviewer by asking some questions. So don't be shy, and also at the same time think about some edge cases. So remember, don't jump into the coding part too quickly. Try to have some nice communication with your interviewer first about like clarification, like understanding the question, and talk about the solution, etc. So don't start to jump into the coding part too quickly. So let's race through this problem. You're asked to design a file system that allows you to create new passes and associate them with different values. So the format of the pass is one or more concatenated strings of the form slash followed by one or more lowercase English letters, for example, /Leetcode and /problems, /Leetcode, /problem are valid passes, while empty string and just a single / are not. So the create pass creates a pass and associated value to it if possible and returns true. It returns false if the pass already exists or its parent pass doesn't exist. Okay, so it says that, okay, so it is going to return true or false for this API create pass. So let's see. The second API is get. So the get is going to return the value associated with pass or return -1 if the pass does not exist. So having said that, let's take a look at this example. Let's say, for example, to file system first, create a pass lead and then create pass Leetcode. Both are going to return true, and then we get Leetcode, then it is going to return 2 because the value associated with this pass is 2, and then we create pass cd, it is going to return false. That is because we haven't created the parent pass, which is /c. So we cannot directly create /c/d. And then we get c/c, then there's no corresponding directory, so we are going to return -1. So let's see the constraints. So the number of the calls to two functions is less than or equal to 10k in total. And the pass length is between 2 to 100. Okay. And then the value is between 1 to a billion, so never going to be some negative integers. Alright, so I think we pretty much understand the question. Not too much to think about the edge case, because we don't consider like the empty string or just a single /. Those are going to be illegal, so you don't need to consider those illegal input case as an edge case because we have clear constraints. So let's think about the solution. So how to solve this problem? So currently what I can think about is so I think there are generally two ways. The first way is we can use a hash map. So the map is going to store the pass and the corresponding value. So this is solution 1. We use a hash map key as pass value as the value associated with the pass. So when we create a pass, we need to separate the pass into different chunks by the /. So for example, let's say we add some pass like /a/b/c. So first of all, we need to make sure that /a exists in the map. And then we need to make sure /a/b exists in the map. And then we need to check if /a/b/c exists in the map. So every time we need to check every parent if they exist in the hash map. If not, then we are just going to return false. Otherwise, if /a and /ab both exist in the map, we just need to see whether /abc exists. If it doesn't exist, then we are going to return true and add /abc into the map, and then set the value as corresponding value. So when get, we just need to get the corresponding value from the hash map. So this is solution 1, which is a pretty good one, but space-wise I think it's going to waste a bit of space. And there is another solution, so solution 2. So for solution 2, what I can think about, we can use a prefix tree or trie to solve this problem. So every time we create a pass, we need to see, so before the leaf node, let's just say we have /abc. You're going to create a pass like /abc, so we need to make sure that under the root node there is a corresponding child, which is a, and after the a there is corresponding node, corresponding child, which is b, and for the children nodes of b, so we check if there is already a child with the node as c. So if we already have the c node as a child of b, then we are just going to return false. Otherwise, we are going to add the new child node into b and set the corresponding value. So for get, it is pretty much just split the pass using the / and then go to the corresponding branch. So if during the time we go to the corresponding branch, if there is nothing, then we are going to return false. If we can finally achieve the corresponding pass and the node has a value, then we can say that we can return the corresponding value for it. So both things are I think both things are very similar regarding the runtime. So for solution 1, the create pass is going to, so let's say we split it and then we recompose it. So it is going to be, I would say, let's say if we first split it and then recombine that, it is going to be, I suppose the pass has n, the length of the pass is n, then it is kind of like a n, I think it's kind of like an n square solution to me, because we need to we need to get /a, then /ab, and then /abc. So kind of let's say we have C chunks, like C different subdirectories. Then for this one, it is going to be C to C square regarding runtime. For create pass, for get, it is going to be all of 1, which is constant. For the trie solution, the create pass is going to be OC. And then for get, the runtime is also going to be all of C. So I think both solutions make sense. So just some trade-off, I think. And also the trie solution is going to save some memory, because we don't need to store all the prefix. Suppose we have ABC, you don't need to store A and then AB. When we store AB, we kind of use some extra memory here. So I think both, I would say both are fine. Just talk with the interior which way is preferred to go. But for this one, let's go to the trie approach because it is a bit more complicated to implement. So for the trie solution, we need, first of all, we need to define the trie node here. So for the trie node, we have the children. The children is going to be key as a string, value as a trie node. And also it will have the value. Let's give it some constructor. So we're going to say children new Hashmap is equal to -1. And let's define the tree. So let's define the trie. So for the trie, we have the root, and then we will have a trie here. So let's say the root is equal to new trie node. Alright, so currently I think we should be in good shape. So let's see, for the file system, we are going to have, so we have the trie, which is root. So root equal to new trie. Alright, so then let's implement the create pass. So for the create pass, we are going to let's say split the chunks, pass.split using the / and then we go through chunks.length -1, then plus I. So let's see, trie node, let's say the node is equal to root at the very beginning. So we are going to go into the corresponding branch for the, let's say if it is ABC. Let's say if it is ABC, then first of all we are going to go into the A child, then the B child, then the B child of A, child B of A, and this is the for loop. And then when we are at child of B, we need to check if the last one exists or not. If exists, then we return false. False. Otherwise, we return true. And set the corresponding node value. So, and also along the path, we need to make sure that /a and /ab it does exist. So let's see. So if node dot children dot, if the node doesn't contain the key which is chunks I, then we are going to return false. Otherwise, we are going to say, okay, node is equal to node.children dot get chunks I and go. So if so let's take the example ABC. So if let's say if A, we try to create a path which is ABC. If A doesn't exist, then we're just going to return false here. Otherwise, we are going to go to the corresponding branch, which is /a. So this for loop is something for this kind of purpose. And finally, so let's say for this example, we are actually at B. So if node.children contains key chunks, this is chunks.length -1. So if it already contains the last key, so let's see. So it says create a path, create a new path and associated value. Return false if the path already exists or its parent path doesn't exist. So if it already exists, then we are just going to return false here. Otherwise we need to otherwise we need to say, okay, node dot children dot put chunks. So let's say the last chunk. So this is last chunk. So this is the last chunk. We are going to put the last chunk and the new try node. And then node is equal to node dot last children dot get last chunk, and the node dot value is equal to the value, and we are going to return true here. So this is create pass, and for the get pass, it says return the value associated with the pass, or return -1 if the pass does not exist. So again, we are going to split it. So we are going to say, okay, I is equal to 0, I is smaller than chunks dot less plus I. So you have the node, so tree node starting as root. So if the node, so if we don't have a corresponding child here, so we don't have the corresponding chunk here, we are just going to return -1. Yeah, otherwise we are going to go to the corresponding child node. So node dot equal to children dot get chunks I. Okay. Yeah, and finally we are just going to return node dot value. Because we have the default value as -1, so if the pass doesn't exist, then we are going to return -1, which is fine. So let's render this one. So try node, let's say 13. Okay, so another compile arrow. So this is, oh, okay, so this is a typo here, so this is a try node actually. Try node. Yeah, actually you don't need to define the try here because yeah, so this is just some try node is fine. You just don't need to define the try node. We don't need to define the try here. So it's wrong answer. Let's say why it is wrong. So we have the try node defined as children value. Okay, so we have the root which is starting from try node, and then we split the, so let's say we create a pass /a and 1. Okay, so the length after doing the I see. So essentially cannot really, if we use a split A, then we are going to have like the space and then an A, which is not what we want. So the first one is not what we want, so we just start from 1 here, I think. So this is also starting from 1. Alright, so this one, it is fine after we fix this. Okay, so it seems to be fine. Let's do a submission for it. Alright, so it seems like everything works well at this moment. So that's it for this coding question. If you have any question about the solution or about whatever, feel free to leave some comments below. If you like this video, please help subscribe this channel. I'll see you next time. Thanks for watching.